Let's start chapter number 9, the kinetic particle model of matter. States of matter, the three states: state, shape, volume, flow, and compressible. These properties are given here. So you can see in solid state, the shape of the matter is a fixed shape, the volume is fixed volume, and there is no flow. As these are solids, they don't flow. And compressible, no, because particles are very closely tied with each other, so they will not compress. In liquid state, the matter has no fixed shape, it has fixed volume, and yes, it does flow, and almost uncompressible. In gaseous state, the matter has no fixed shape, no fixed volume. Yes, they do flow, and yes, they are highly compressible because they have larger space between their molecules. So they can be compressed. Example is gases. All right, changes of state, physical changes. In melting, the state of matter change from solid to liquid. In freezing, the liquid to solid change occurs, and then in boiling, evaporating, the liquid changes to gas, and in condensing stage, the gas changes to liquid. Now some important points: mass and number of molecules stays the same, only energy and arrangement motion of particles change. Changes of states are reversible. Physical changes, not chemical changes. So physical changes are the changes which occurs physically, and they are reversible. However, the chemical changes are not reversible. Molecular matter, particle model, particle arrangement and motion. Here the solid, we have some properties. Particles very close together. They have regular pattern, only vibrate about fixed position. Strong forces, fixed shape and fixed volume. In liquids, particles are still close together. There are no big gaps, but there is no fixed pattern as well. In liquids, it can slide past each other. They have fixed volume but no fixed shape, and they can flow. Gaseous, particles far apart, about 10 times further than in solids, move very fast randomly in all directions, almost no forces between them, no fixed shape, no fixed volume, and can be compressed. Forces between particles. Let's talk about solid. Very strong attractive forces, particles held in place. In liquid, forces are weaker, enough for particles to move but stay close. Gaseous, the forces are negligible. Particles moves freely far apart. This explains why solid don't flow, because the molecules are very closer to each other, tightly packed. Why liquid flows and are not easily compressible? Because there is some molecular gaps between the molecules. However, these gaps are not so far from each other. Why gases flow and are easily compressed? Because there is large gaps between the molecules of the gases. So if particles are far apart and move fast at random, most probably it is gas. If close together and move randomly with no fixed shape, this is the property of liquids. Now let's talk about temperature and internal energy. When a substance is heated, particles moves faster. So kinetic energy increases. Internal energy is equals to total kinetic energy plus potential energy of particle, that also increases. Increased particle motion can lead to higher temperatures or change of state if energy breaks forces instead of raising temperature. Now let's talk about temperature and pressure in gases. Motion of gas particles. Gas molecules are in constant random motion at high speeds. They collide with each other, the walls of the and with the walls of the container. Pressure in gas. Pressure is caused by particle collision with the container walls. Each collision exerts a tiny force on the wall. Many collisions means overall force and then it exerts pressure. Effect of volume. Compressed gas, decrease volume, same temperature. Particles have less space, hit walls more often, more frequent collision, pressure increases. Expand gas, increase volume, particles hit walls less often, pressure decreases. Now let's talk about Brownian motion. What is Brownian motion? Random zigzag motion of small particles like pollen or smoke suspended in a liquid or gas due to collision with invisible small particles, atoms, and molecules. This kind of motion is called as Brownian motion. Observed under a microscope, smoke or pollen grains jiggle randomly. Explanation. Tiny, fast moving air or water molecules hit the larger particles from all sides. These random nudges make the larger particle move in an erratic path. Why it's important? It gives evidence that matter is made of tiny particles. These particles are in continuous random motion. Now let's talk about gases and absolute temperature. Absolute zero and Kelvin scale. As gas temperature decreases, particles move slower, collide less, pressure drops. At absolute zero, particles would have minimum possible kinetic energy. No net motion, no pressure. Absolute zero is equals to minus 273 degrees centigrade, which is equals to 0 Kelvin. Let's talk about Kelvin scale. 0 Kelvin is equals to minus 273 degrees centigrade. Increase in 1 Kelvin means increase of 1 degree centigrade. Temperature in Kelvin is never negative. Conversion, if we need to convert from Celsius temperature to Kelvin, our formula will be, we will have to do the calculation of temperature. Suppose to Kelvin, we will take the centigrade temperature and we will add 273. And if we need to convert from Kelvin to centigrade, we will take the temperature in Kelvin and we will minus to 273. Now let's talk about gas law. Number one point is pressure, volume, constant temperature. At constant temperature, if volume decreases, pressure increases. And if volume increases, pressure decreases. Reason. Same number of particles, smaller volume. More frequent collision with walls means higher pressure. This is Boyle's law. P is inversely proportional to volume at constant temperature. Or P1 V1 is equals to P2 V2. P1 V1 is initial pressure and volume. P2 V2 is final pressure and volume. Units. Pressure usually in PA or can keep it in kilo PA. MPa if consistent. PA is for Pascal. Volume in meter cube, but questions often allowed centimeter cube as long as both sides use the same units. Pressure, temperature. Now the constant volume. At constant volume, temperature increase. Then the particle move faster, which collide more often and harder. Hence the pressure increase. Higher temperature means higher pressure. Lower temperature means lower pressure. On a graph of pressure versus temperature in Kelvin, we will always find a straight line through the origin as pressure is directly proportional to temperature. So we have a quick small summary. So when temperature increase, what happens with the particles? The particles moves faster, kinetic energy will increase, more frequent and harder collisions will be there. If pressure increase, then what happen? If the volume is fixed, volume decrease, what happens? Same particles in smaller space, more collision. Pressure increase if temperature is fixed. Volume increase, fewer wall collision per second. Pressure decrease if temperature is fixed. With this, we have finished our chapter. See you in our next chapter.